Hello to everyone in this webinar. We are very happy to have our friend from FHIR to present with us the Ontoserver that they have and how it connects to the FHIR, to the ECN7 FHIR standard. Hopefully we can gain some new things from them this afternoon, and after their discussion, we hope to discuss how we can collaborate more because as mentioned before, Hyla has an evaluation copy of the Ontoserver, and we would be very happy to share it with the whole AeHIN community so that all of us can evaluate and see how we can use the Ontoserver in our own use cases. So I think that's it. So let's have our friend from FHIR discuss the Ontoserver. Thank you.
Thank you. I think we might just do some introductions first. My name's Jim Steele. I met some of you in Manila earlier this year at the meeting that we had there before the world shut down. I'm a team leader at CSIRO in our health data and FHIR team. Working with Michael, one of the main things I work on is our Ontoserver terminology server product. And I also do a lot of other FHIR work, working on FHIR standards for data exchange here in Australia, and some other software tools that we work on as well.
I'll go next. Hi everyone, I'm Kate Everall. I also met some of you over in Manila earlier in the year. I'm the product manager around our clinical terminology and FHIR products, a program lead, and prior to joining CSIRO, I used to run the National Release Centre and the National Clinical Terminology Service in Australia. So I was a customer of CSIRO and I implemented Ontoserver within Australia as our National Clinical Terminology Server. We've got two other members of the team who might get to introduce themselves before we come back to Michael, who's going to be kicking ourselves off. John, did you want to just quickly introduce yourself? You're on mute, John. I don't think maybe he's not allowed to talk.
Okay.
There we go.
Hi, I'm John. I also work in the health informatics practice at CSIRO. I work on tools to make analytics tasks easier using FHIR and SNOMED CT. That's me.
Thanks, John. Kylene, I'm not sure if you're able to come off mute or if one of the SALA team has to unmute you.
Hi, hi everyone. My name's Kylene. I am the team lead for the clinical terminology group that sits under Michael and works with Jim. So we mainly work on providing implementation support and advice and develop techniques around using standard terminologies like SNOMED CT, which you would then put into your FHIR server.
Thanks so much, Kylene. So maybe if there are future sessions, you may see John and Kylene taking the lead on presenting some of the topics and information. So Michael, back to you. We'll get you to kick off with the session.
Thanks, Kate. Hello, everyone. I'm Michael Wally. I lead the health informatics research at the Australian eHealth Research Centre. The eHealth Research Centre is approximately 100 staff, students and visiting researchers. We are embedded at the Royal Brisbane and Women's Hospital in Brisbane, in Queensland, but we have people in various other states across Australia. We are CSIRO, but we are also receive funding from the Queensland State Health Department. And that allows us to partner very closely with various parts of Queensland Health, as well as other state governments, state health departments, national bodies, industry, and of course, we work closely with clinicians as well. Got to work out how to control Jim's screen. There we go. Within the eHealth Research Centre, we're broadly operating in three areas: biomedical informatics, health informatics, and health services. The biomedical informatics work covers imaging, biostatistics, and genomics. In health informatics, we deal with health system performance, health data interoperability, and extracting structured data from free text, so natural language processing. And in the health services space, we look at healthcare delivery, new healthcare delivery models, telehealth, mobile health, remote monitoring. So quite a broad remit across the lab. So we're talking about terminology here, but why are we interested in terminology? The main thing is that we need good, precise, and accurate data for delivering safe and high quality healthcare. And that's really what we're about. We're about good quality healthcare, and we're interested in the data insofar as it supports delivering that healthcare. When we're dealing with multiple systems, we need to have shared understanding between those systems. We need common language so that those systems are talking about the same thing when they exchange data, and that's where we bring in terminology. Why do we, what does this actually mean? So as I said, it's the shared meaning between different systems. In terms of the FHIR specification or general information modeling, we have the structures that carry the data. So if you're familiar with things like UML or entity relationships, or even just database tables, these are the things that carry the data. Terminology is part of what populates the data. So we have the values, the reading off a blood glucose meter or something, but then we have to say, well, what medication is being delivered, or what is the actual disease, and that's where the terminology comes in. When we want to deal with interoperability, we need to set up agreements on what's being exchanged, and agreeing on what terminology is going to be used means that we can agree where we're going to understand what's being said in different systems. Some terminology is extremely complex, and I'll talk a bit more about that further on in the talk. That includes things like SNOMED-CT, and because of the inherent complexity of the semantics that it works with, we don't want everybody implementing or needing to implement a complex technology to deal with that semantics, and so that's why we're looking towards externalizing that semantics into a separate service, and hence Ontoserver and the FHIR Terminology Services API. So terminology affects a number of things that you might want to do when you're dealing with data. When you are recording data, you want to find the right code to enter into a field. If data has been passed to you, you may want to validate that the codes that you've been given make sense for the context that they're being used in. So that's the basic data validation use case. If you're doing analysis or trying to understand the data, you may need to look up the code and find out details, properties of the code, what its synonyms are and so forth, how it relates to other codes. If you have codes from multiple code systems, you may need to do mapping. So you may need to find codes from one code system that relate to codes in another. When you're doing analytics, you're likely to want to aggregate up detailed or fine-grained codes into broader categories. So grouping codes together is another action you might want to perform. And of course, if you're setting up agreements of what data you're going to exchange in FHIR, this is the notion of profiling, which you record in an implementation guide. Then you're likely to want to define your own value sets and concept maps and possibly even additional code systems to say these are the things that we're talking about in this context. If you're actually implementing a FHIR server or implementing an API over an existing system that provides a FHIR API, there are parts of the FHIR API, such as its search capability, that naturally interact with terminology semantics. So you may want to use an external terminology server to help you implement those pieces rather than having to build that smarts yourself. So where do you find codes in FHIR? Well, there are a number of different data types in FHIR that relate to codes. There's the code data type. This is a primitive data type, and it's just the code from context, and the context will be either the resource, the underlying resource that the code type field exists in, or from a structure definition in an extension. Finding an extension, it will fix the code system, and so you just need to record the code. In the coding data type, you record the code system, possibly the version of the code system if that's necessary, the code itself, optionally the display text associated with that, and even a boolean to say whether or not this was a user selected code, it's not always user selected. Sometimes it's prescribed by context. The last main data type is the codable concept. This is the sort of most general form of the way you can represent coded data in FHIR. It allows you to provide one or more codings, and these codings would generally be codes from different code systems that mean essentially the same thing. An example where that crops up is in the pathology space, where HL7 mandates the use of certain LOINC codes, but other jurisdictions that don't use LOINC might want to use SNOMED codes instead. So you might need to use multiple codes in that case. And sometimes there just isn't a code for what you want to say. And so you need to fall back to some free text. And so codable concept actually allows you to record free text as a fallback. In the search API, there's also a thing known as a token. And this is really just a literal syntax that allows you to refer to a code system and a code so that you can pass those into the REST API when you invoke operations. So to make that a little bit more concrete, here's a sample FHIR resource for an encounter, and we'll see the three different data types appearing here. We have the code typed status field with its code value in progress. We have the coding typed class property, which has a code system URI and the code. And then we have a codable concept typed field, the reason code, which has a coding with two codes in it. So there's this SNOMED code from a specific version of SNOMED, and this one was user selected, and then it has an ICD-10 code as well. And maybe this came from the underlying profile, or maybe it was automatically added in by the system as a result of this user selected code. And then we also have the optional free text. So this may be the text that was displayed to the user in the form when they entered this data. So I've alluded to a number of FHIR terminology resources, and now we'll look at how they relate to each other. The core one is the FHIR CodeSystem. It's a normative resource. It defines a set of concepts, the metadata associated with the code system, so it's URL, the version, the name, and also all the codes and the details of those codes, the display text, any synonyms, any properties that it may have. So it's the main foundation of the terminology subsystem. The next piece is the value set. And the value set is the workhorse. The value set allows you to select a subset of codes from one or more code systems for use in a particular context. Often that context is a data entry field or for binding to a resource. And the way a value set selects those codes, it may be it just identifies a specific list of codes, or you may use certain rules to include the codes that match the rules. And those rules can have inclusion criteria and exclusion criteria. And then the last piece is the concept map. So concept maps allow you to define a mapping between source and target concepts. They are scoped by a source and target value set, and associated with the mapping, you specify a relationship between the target code and the source code. So often that's one of equivalence, but sometimes it's a different relationship. The target code may be wider than the source code. It may be narrower than the source code, or it may not be equivalent. It may just be related to it. So there's a number of different predefined relationships you can use there. Being a subpart of FHIR, the terminology resources are just like other resources, and you can interact with them using the normal RESTful FHIR interactions for searching, creating, reading, updating, and deleting, the so-called SCRUD operations. And you can see here, you can use GET or POST requests to perform some of these operations. So a search, you can do with a GET or a POST. You provide the search criteria as the parameters to the request. To create a resource, you post it. To read a particular resource, you use a GET operation. Some servers will also support a history, so you can see previous versions of a resource. So if you've overwritten a resource, you can go back and look at previous versions, and Ontoserver supports this for all the resources it stores. You can update a resource with a put, and that's how you get your new versions. And of course, you can delete, and delete also leaves a trail in the history. Those are the basic the basic operations or the basic interactions. Where the operations get interesting is with the specific operations that you can invoke on particular resources, and we'll look at some of those in the rest of the talk. They all have a format where the operation is preceded by a $sign. They can be invoked at the root level of the server, or on a given resource type, or on a particular resource instance. Note you can't invoke operations on historical instances of resources, only on the most recent instance. So let's look at some of the use cases we might have and how we can use parts of the FHIR API to deal with those use cases. The common one is the data entry use case, and here you need to decide what code system or code systems are relevant for your field. You define a value set that identifies a set of codes that you're going to accept for that field. In a user interface, if that value set is small, you might use a pick list. If your value set is large, then you're probably going to need some kind of type ahead widget so that as you type, a drop-down list appears and you can choose the best match. And for this, the expand operation for value sets is the operation that you would use. It takes a filter parameter as the main parameter, and its value would be the text that the user has entered. And expand will return the best matching codes from that value set. Given the time constraints, I don't have time to demonstrate this. But if you take a note of this, this link, there's a sample user interface. It uses exactly this API and for these various fields, and you can go in and play with that and see how the API is used to provide that sort of dynamic and interactive data entry capability. So what does expand really do? Expand takes your value set definition, so those inclusion and exclusion criteria. It evaluates them with respect to the code systems that it references, and gives you the members of the value set that satisfies those criteria. It further applies any parameters that have been provided to the expand operation to adjust what it returns. So you can provide a count to limit the number of results. You can provide an offset field so that you can page through the results. You can ask for all the synonyms of the concepts to be included in the result or not. The definition of the value set to be included in the result or not. You can exclude inactive concepts. You can specify a preferred language for the display text to come back in. So if you've got translations of your codes, you can say what languages you want them to be returned in. And of course, you can provide the filter text to say, only give me the members of the value set that also match this filter text. And this is really one of the workhorse operations of the specification. Now, unfortunately, I have to head off to another meeting now. So I'm going to hand over to Jim and leave you in his capable hands to complete the presentation.
Thank you, Michael. So what I'll show here first is just a few quick examples of that expand operation that Michael has very ably described for us. So this first one, actually, if I go back. So this first one is, we're calling the expand operation. The first parameter we give it is the URL of the value set that we want to expand. So in this case, this is this administrative gender value set. This is one from inside the FHIR spec. And that's the only parameter we're going to pass this invocation of expand. And when we do that, what we get back is this resource on the right over here. So that shows a value set as the result that comes back from the expand operation, and it has an expansion element in it. So this is the result of the expansion. It tells us what parameters the expansion was called with. So in this case, it was just which value set URI it was. And it comes back with the 4 codes that are the member of that value set. And for each code, it has a system, a code, and a display text. And it has to have that system because value sets can have codes from multiple code systems. So the next example, in this case, we're going to call the expand operation. We're going to use this URL, http://loink.org/vs. And this is actually the implicit value set for all of the codes in Loink. which is, it's a very big value set to use, but it's what we're using for this example. And we're also going to pass through two other parameters. The first is a filter parameter. So that's a text filter that maybe the user has typed in. So in this case, urinalysis. And we're going to give it a count parameter to say we only want the top 3 codes to come back. And the result that comes back is, again, a value set with an expansion element. And it tells us that that count parameter was passed in and that there was a urinalysis filter put on this. And it comes back with these top 3 codes, which are these LOINC codes, urinalysis panel, and urinalysis studies. The final example I'm going to use, in this case, we're calling the expand operation, and we're not going to tell it which value set we're interested in. What we're going to do is tell it which field of a resource we're interested in. So in this case, we're going to say, I want to expand for the context that is the status of a medication. And what the server will do in this case is it will look at the medication resource and the status field within that resource. It'll look at what value set is bound to that field, and it'll expand that. So in this case, when we see the result of the expansion, it'll tell us that the value set it expanded was this, this value set URL here. And it's come back and it's got these 3 codes, intervenero, active, and inactive. So the next use case we'll talk about. So as Michael said, that one of the other common things we want to do after data entry is when we receive some codes, we want to check whether those codes are appropriate. So maybe we receive a whole record and we want to check for each of the different fields in the record whether the coded values we've got are appropriate for that field. And what we're going to do that is, first of all, we choose which code systems and value sets we expect for each of the fields. And then we can use the validate code operation to work out whether the codes we have received are correct with respect to those code systems and value sets. And then probably once we receive data, we'll do some other things. We probably do some mapping to translate some codes across, and maybe we'll use the subsumes or closure operators to maybe categorize some of that data. We won't get into those operations in this presentation, but if you're interested in them, they're in the spec. So that validate code operation, what it does is it takes a code that's provided and it takes a value set, and it just tells you whether the code is a member of that value set. So you can either give it an existing value set by providing a URL, for example, or you can post in a value set when you call the operation. And that allows you to do sort of responsive UI type things where the validate code operation you're doing depends on what values have been entered elsewhere in the system. For the code, you can either pass that in as a code in a system, and if you want to narrow it to a specific version, you can pass that in as well, or you can pass in a coding or a codable concept. The other thing that validate code can do is it can actually check the display text that's been provided with the code as well. So if someone sends you the code for, say, cancer, but then they've changed the display text and the display text says diabetes or something, then that's something you want to know about, because clearly there's a conflict within that data, and validate code can also detect that as well. So if you pass in some display text to validate code, it will check whether that's acceptable display text for the code that you've provided. So here's a first example of that. So what we're going to do here is the URL we're going to use, which is the URL of the value set. That's snowmed.info/sct?FHIR, and that's the value set for all of the codes in SNOMED, which is, again, it's an awful lot of codes, and most fields that you have in a system would be much narrower than that. But for this example, we'll use that. And then for the code, we pass in both the system and the code, because remember, value sets can have multiple code systems. So we'll pass in this case, a SNOMED code 383.62002. And when we do that and we call that operation, the server will come back and it'll say, it'll give us a result which says, yes, that code is a member of the value set that you asked me about. And just to be convenient, it'll also tell us what the display text of that code was. So in this case, it's dengue fever. Here's another example of this. So what I'm doing in this case is, once again, I'll use all of SNOMED value set, and I'll pass in a SNOMED code, in this case, this 136.44009, and I'll pass in the display text. So maybe I've received a record and it says, this is what the user said this code was for, and it's hypercholesterolemia. And in this case, the server will come back and it'll say, oh, yes, that code does exist in the value set, but the display text you provided is not correct. And because it actually gives us the correct display text here, we can see that this one has an AE and the one we passed in just had an E. So there's a spelling discrepancy there where the user's misspelt it, which is something we can work with when we're analyzing the data. So the last operation I'll describe here is the lookup operation. So this is for where we're exploring a set of concepts and we want to know how they interrelate and what their properties are. And maybe we want to display all those things in a table or in some other tool that we can use for exploring the codes and their relationships. So an example of this is the shrimp browser that we've built at CSIRO, which you can use to browse code systems. So shrimp uses the lookup operation fairly extensively, along with a bunch of the other operations from the FHIR Terminology Services API to retrieve information about the code. So in shrimp, if you notice this little table down the bottom here, most of that data is provided by just doing lookup requests on the code. So you can search for code on the right here. Once you've selected it, it'll populate this table down here by doing a lookup operation and telling you what all the properties of the code are. So that operation is very simple. You just pass in a code, and much as we did for the previous operations, you can do that by providing a code and a system URL, and optionally a version, or you can pass in a coding or something like that. It can also retrieve specific properties of the code. So there's a property parameter you can pass in where you can say, I want this specific property to come back. If you don't do that, then the server's kind of free to provide whichever properties it thinks you might be interested in for the code. So here's a quick example of that. So in this case, I'm using a custom code system that I've built myself, which is all of the states in Australia. So I'm going to do a lookup operation. I pass in the system, which is the system URL of the code that I'm looking for. And that's my system for my custom code system. And then I pass in the WA code and the server comes back and it says, yep, okay, the name of that code system is the Australian Jurisdictions Code System. It's version 0.0.1. The display text of the code you submitted is Western Australia. It's got a designation, which is what FHIR uses for capturing synonyms, among other things. So it says a synonym for this code is West Australia. So that's also an acceptable synonym. And its parent is AU state. So it's given me those properties back. And that code may have other properties as well, but the server's decided those are the important properties that it wants to tell me about. So that's what it's returned. So just as a quick diversion, FHIR actually has specific things to say about certain code systems. So there are certain code systems like SNOMED CT, like LOINC, which is used a lot for pathology and lab coding in places like the US and Australia. ICD-10, which is used for mortality and morbidity classification, among other things, often billing as well in a lot of countries. Terminologies like this are very complex and are very commonly used. So FHIR actually says things about how it expects those code systems to be used. So some of the things that it will do is it'll define exactly what the URL for those code systems has to be and has to look like. It'll say what properties can exist on those codes and what filters you can use on those code systems when you're trying to assemble value sets. And it can define what are called implicit value sets or implicit concept maps. So these are, for example, value sets that as soon as you add one of these code systems into your terminology server, then you should be able to expect all of these value sets to be there. And I'll show a couple of examples of those. So on the left here, we have all of the information about SNOMED. So it's got this http snomed.info/sct. That's the URL for any SNOMED code system that goes into a FHIR server. And then it has a version format as well. So if you put /addition with the addition code and the version code and then a date, that's what the version syntax looks like for SNOMED code systems. For properties, all of the relationships that are defined in SNOMED are available as properties on codes. So if you do a lookup request, you can ask for any of those properties and the server should be able to give it to you. And those are all there as filters as well. So if you're building a value set and you want to define your value set using filters, then you can use that using the SNOMED relationships to build those. And it comes with a bunch of implicit value sets. So there's this implicit value set here with the FHIR VS. That's the one I used in a couple of my examples. That's all of the codes in SNOMED. You can also, there are implicit value sets by subsumption. So if you, at the end of that FHIR VS, you put is a / and then some SNOMED code, that will represent the value set of that code and all of its descendants. So you might be interested in diabetes and all of the more specific types of diabetes. And so you don't have to build that value set yourself. You can just build this URL by putting the diabetes code at the end, and you'll have that value set implicitly for free. There's a value set that is all of the ref sets that come with that SNOMED distribution for all of the codes in a given ref set. And then value sets for all codes that match a certain ECL expression. So ECL is a language defined within SNOMED for querying the relationships that are part of that SNOMED model to find a bunch of codes. So you can use those ECL expressions in implicit value set URLs as well. And the same thing exists for LOINC. So LOINC has a bunch of axes that define a LOINC code. So what method, what system, what component, and things like that. And so you can build implicit value sets by that as well. So you can ask for all of the LOINC codes that descend from some LOINC part in the LOINC hierarchy. And these value sets just exist as soon as you've added a LOINC code system into your server. So those are the main code systems in FHIR that come with these extra bits of detail that are specified. But for code systems like ICD-10, for example, the FHIR spec will tell you what the URL for that code system should look like, and a couple of the properties that you can expect to exist. So the last use case I'll talk about now is the authoring terminology resources use case. So there's a bunch of cases where you might need to do this. So if you're creating a new user interface, maybe you need to create some new value sets for the different data entry fields that you want to use in your user interface. If you're making FHIR profiles, so perhaps you're defining what a patient resource should look like in your country, then you might need to create some new value sets for bindings within that profile. I imagine an important thing for this audience is that you need to represent local codes as a code system resource. So for example, if you're in Thailand and you're using the Thai medicines terminology, then you need to create a code system resource for capturing all of those codes and the relationships that exist between them and the properties that they have. So that's an authoring use case. Or maybe you need to create a new concept map. So you've got a local code system that you use and you want to map it to some standard code system, perhaps ICD or perhaps ATC for drug usage or things like that. So in order to do this, what you need to do is you need to look at the structure of the resource. So we'll start with the code system resource. The first thing it has is a bunch of metadata. So the most important metadata is the URL and the version. And that's the most important because that's what's used to identify the code system when you're building value sets that reference that code system. Then there's a whole bunch of metadata you can set that tells you information about who's made this code system, where it should be used, and so on. There's a few elements that can change how that code system behaves, so whether it's case sensitive or not. And then you can define properties and filters that can be used on this code system. So for example, over here on the right, I've got the start of a code system for Australian states that I've done, just as an example. And I'm saying down the bottom here that there are two properties that you might see on each concept that exists in this code system. So there's a capital property that could be populated, that's a string. There's a neighbor property that could be populated, and that's a code. Then, of course, the most important part of the code system is what are the concepts that exist in that code system. So you include these concepts in the structure of the code system resource. They can be nested, so that nesting you can use to represent hierarchy. So in this case, I'm saying that the Australian jurisdiction has a child code which is an Australian state, and Australian state has a child code which is Western Australia. And then we can define a whole bunch of synonyms for those codes, and we can define properties for those codes as well. And then we can use those synonyms when we're searching for a code using the expand operation, or we can use those properties when we're building a value set using a filter, for example. One of the other special types of code systems that is interesting for non-English speaking jurisdictions is code system supplements. So supplements are a mechanism that allows you to extend a code system that you're using from somewhere else. So if you're using something like one of the HL7 code systems that comes from the FHIR spec, the chances are it will only have English terms in there, for example. And one of the first things you want to do in another country is you want to define local language synonyms. And code system supplements are a way that you can do that. So code system supplements allow you to override the display terms of codes in the code systems. They allow you to add new synonyms to codes in the code system, and they allow you to add properties to codes in that code system. What they don't allow you to do is to add new codes to that code system, but it will let you do those other things, which is really important if you want to do a local language translation of the code system. And the way you do that is you set the code system content element to be supplement, and then in the code system.supplements property, you tell it which code system it is that you're modifying. So if you're modifying the HL7 administrative gender code system, you put that in the code system.supplements element over here. The value set resource is the last one I'll just mention briefly. So it has the same metadata essentially as the code system, a URL and version for identifying it. And then importantly, the code system, the value set resource has this compose element, and the compose element allows you to define a series of include and exclude rules. And for each of those, there are 4 types of things that you can do. The first is you can include a whole code system just by providing its system and nothing else. You can provide, include or exclude a list of codes by providing a system and then a concept block like this. You can define filters. So up the top here, we've got an example where we've got a filter that says concept descendant of AU state. So that will include any code that satisfies that filter. The one I haven't listed here is you can include other value sets. So you can call off to another value set and say, if the code is in this other value set, then it will be in this new value set as well. And then you can combine them. So what you can do is you can say, provide a different value set and filter. And the only things that match will be things that satisfy both of those things. Or you can do 2 separate includes and put in those things, and it'll be any code that satisfies either one of those. So you can sort of build up these rules using AND and OR combination to get the set of codes that you really want in your value set. And then as we saw earlier, once you've done the expand operation, you'll have that expansion element in your value set, which is the actual codes that have matched whatever the expand request it was that you sent in. So I'm just going to skip quickly through the concept map resource. I'll leave for later. I think these slides will be shared around later for people who are interested. I'll just do a very quick summary of Ontoserver. So what I've described, and Michael, what we've described so far has been just about the FHIR Terminology Services API. It's not been specific to Ontoserver. But Ontoserver is an implementation of this specification. It's designed to be turnkey, so it works out of the box without too much configuration. It's high performance, so it's designed to be fast enough for those type ahead, expand with filter operations. And it's an it aims to be a very faithful implementation of the FHIR standard. So in our view, it's the most complete implementation of that terminology services part of the FHIR specification. So it has fast value set, expand and search, and that has ranking algorithms. So with Ontoserver, when you provide a filter, the codes that come back will be sorted in order of the best matches. So the best match against your search term will be the first code that comes back using a ranking algorithm that we've worked on for many years. It supports arbitrary FHIR code systems. So if you build your code system using JSON or XML, as we've just seen, that will work with Ontoserver, and it also has special support for SNOMED CT and LOINC. It's got a very deep support for SNOMED, so it supports all of the SNOMED implicit value sets and concept maps. For code searching, it has an algorithm, as I said, that we've tuned over many years that works on the basis of term prefix any order. So if you type in ACU DIA, then it will come back with acute diabetes. The other thing I'll mention, it does have a model for sharing content between different servers. So if you have, for example, a national server that's providing code systems or mappings or value sets that are of national significance, and then you have another server, Ontoserver has a mechanism to connect those two servers together so that maybe your local server can pull content from a regional server. And if what I've got here just as a last slide before I hand over to Dr. Raymond is if you're interested in creating some terminology resources for use with the Sila Ontoserver, then there are some tools here that you might be interested in using. So Snapper is a lightweight web-based authoring tool that allows you to create code systems, value sets, or concept maps in a web-based UI. And then you can download those as JSON, or you can upload them directly to a server. There's some conversion tools that we've released as open source as well. So if you are dealing with terminologies or classifications that are released using the CLAML format, the classification markup language, then we have a tool that can convert CLAML files into FHIR code systems. And likewise, if you have terminologies that are distributed as OWL ontologies, then we have an open source tool that can convert OWL ontologies into FHIR code systems as well. And alternatively, if you don't want to use those, then you can always make your own, either by hand editing JSON or XML, or writing programs that generate JSON or XML out of some other input, which is something that we've done quite a lot in different projects that we've done over the years. If you've got more questions, so there's a lovely picture of Michael, please jump onto our Ontoserver website and have a browse. It is linked from the page for the Sila Ontoserver as well. And we do have a Slack channel. If you're really interested in and want to jump on that, then I'm sure we can make that available as well. So I'll hand back over, I think, to Raymond. Are you next?
Yes, thank you, Jim. Let me just share my screen. I only have, okay, I only have like 3 slides. I just wanted to share our activities over at the Standards and Interoperability Lab Asia. The work that we have been doing has been trying to align with folks and our partners over at CSIRO, specifically with regards to, well, essentially spreading the gospel, quote unquote, on the importance of terminology services for healthcare interoperability. This is the URL for the Ontoserver instance. This is an evaluation Ontoserver instance that CSIRO has graciously lent to Sila and to ADB. So for those who are interested to access the Ontoserver, just play around with it. This will be the link that will bring you to that. One of our, well, shall we say, major events for this year is the HL7 FHIR Dev Days 2020. Sila is one of the recognized official partners for Dev Days 2020. For this year, it will be virtual. It will be held from November 17th to 20th. So for those who are not familiar with Dev Days, it is the biggest FHIR-only event globally. The 3 tenets for Dev Days is learn, code, and share. So learn, code, and share. There will be, well, it will feel like there will be hundreds of tutorials, hands-on exercises, presentations, keynote presentation. So, and then this is where the FHIR experts really gather each year and then get together. Most Dev Days, so a typical Dev Day, like for example, it will start very early in the morning, like 7 or 8, and then it could go up until midnight or maybe even past midnight, just for those who are really into FHIR development and all of the work and networking that happens during this 3 days. And then the work that we have been doing has been really to propagate the use of FHIR, the value of it. And for those who are interested, perhaps you could submit presentations or proposals for you to be able to present during Dev Days 2020. And lastly, on December 7th to 9th, we hope to be able to conduct a session during the Global Digital Health Forum. Again, this will be different from previous Global Digital Health Fora, wherein this one will be held virtually. And what we will try to aim will be to be able to sort of demo our proposed use case for the AeHIN general meeting, which was supposed to be July of this year, but because of the pandemic, had to move next year, perhaps indefinitely. The tentative place was to be in Hanoi in Vietnam. The demo was all about the use of FHIR, the use of OpenIMIS, international patient summary, and also Ontoserver. So the use case was to have someone be able to transmit the information regionally that will be in cross-country or cross borders for that particular use case. So thank you. I will not take any more time because this is really a terminology services webinar. And for those who are interested in our proposed schedule of activities for the rest of the year, particularly for terminology services, so SILA, together with CSIRO, is planning a set of capacity building activities through webinars and also through targeted approach. That will mean identifying several partners in different countries, at least 3 different countries in the ASEAN region, and also much more granular in terms of for those health facilities, hospitals who would be interested in learning more about terminology services. Please approach SILA and CSIRO, and we'll be more than happy to help out. The work that we will be doing really will be sort of a research and having a demonstrated output in terms of how Ontoserver, the use of national license for if you have a SNOMED license, for those countries also that are using their own terminology, and code classification systems, like for example for Thailand, we understand our AeHIN chair, Dr. Bunchay Kijsayanutin, has been heading the Thai medical terminologies or TMT, so that's something to be of note. And for other countries who are interested to partner with us, with AeHIN, SILA, and CSIRO with regards to terminology services, please feel free to reach out and we'll be more than happy to help out with your terminology needs. Thank you.